Hello, good morning everyone. In the last few classes we discussed about flip-flop, various type of flip-flop. A flip-flop which can be used to store a single bit data of informations, which can be either zeros or one. But in digital electronics, we want to store a group of bits which can be called a word. Then we need to use a group of flip-flop. We have to use a group of flip-flop in together. Such groups of flip-flop are called the registers. So registers are nothing but a group of flip-flop, and this is the simplest definition of a flip-flops. Now, this is the simpler definition of a register. So in this class, we study in detail about the registers. Basically, there are two type of registers. One is the buffer type of registers, and other one is series shift registers. So we will discuss in details about these two types of registers. Hence, register is a device which is used to store such group of informations, that is a word of informations. Basically, it is a group of flip-flops connected in series used to store multiple bits of data. So if you want to store n-bit informations, n-bit register, so we need to use an n-bit register. So if you have to use n-bit registers, we need to use n number of flip-flops. So that basically, if you want to store 2-bit data, we need to use 2 flip-flops. If you want to store 4-bit data, we need to use 4 bits flip-flops. So generally, this flip-flop will be connected, clock pulse connected, so that it will respond according to the clock pulse. No, it can be a positive triggered clock pulse or negative triggered clock pulse. So here you can see a 4-bit register where you can see that the clock signal is connected to all these 4 flip-flops, and the informations are given in I1, I2, I3 and I4, and the outputs are taken along Q1, Q2, Q3 and Q4. A buffer register is a simplest type of registers which is used to store a binary word of informations. So which is normally used as a temporary storage of informations. It can be either while writing or reading information from memory. The circuit diagram of a 4-bit buffer register is shown here, and you can see that a common clock pulse is connected to all these 4 flip-flop. Since it is a 4-bit buffer register, we need to use 4 flip-flops. Here you can see that we in the registers we just want to store data and we don't need to toggling. So generally D type of flip-flops will be used for buffer register. This is the simplest type of registers. You can see that B1, B2, B3 and B4 which are the inputs, and here we are applying the binary data informations as the input, and Q1, Q2, Q3 and Q4 are the output terminals. So when all the flip-flops are synchronized with a clock pulse, data inputs are loaded into the flip-flops. So it will happen simultaneously when a clock pulse is synchronized, given to all these 4 flip-flops, that whatever data given to B1 will be reflected in the Q1, Q2, Q3, Q4. It will be reflected here. So the relation between the outputs and inputs are this one. The Q1, Q2, Q3, Q4 is equal to B1, B2, B3, B4. Here you can see that there is no control over the inputs, which in turn leads to uncontrolled outputs. So that is one of the limitations of buffer registers. It will immediately respond to what is given into the input, and it keeps also there is no control over the inputs as well as the corresponding outputs. The bits stored in shift registers, which can be made to move within the registers, in or out of the registers by applying a clock pulse. So such registers are called shift registers. So in a shift registers which is capable of shifting the binary information to the right or left. The serial shifting, there are two types of shifting. One is called the serial shifting, where the one bit at a time for each clock pulse. So one bit of information will be transmitted for each clock pulse. Whereas in parallel shifting, all the data gets shifted simultaneously during a single clock pulse information. When there is a single clock pulse. So depending on that, we can classify. There are four type of shift registers where the serial one is called the serial input, serial output. So where serial data will be inputted, that is the information will be input into the device one by one bit at a time for a single clock pulse, and the output also will be taken like that. So output will be taken out of these registers by as a one bit of information at a time. So this is called serial in, serial out, and there is another one is called serial in, that parallel out. So the second type of register is called serial in, parallel out, where the data will be input into the register as a single bit of information, whereas the output is taken at a time. So we can take all the output information at a time. So that is called the serial input, parallel output. So this is called, the first one is called SISO and second one is called SIPO. And the third type of registers is parallel data inputs, serial data output, where the input will be given to the registers at a time, whereas output will be taken one bit at a time. That is called the PISO. And the fourth type of registers where data input into the registers as a parallel data input, and it will be taken out of the registers as also parallel data of information, where all the data get shifted simultaneously for a single clock pulse. For in your syllabus, you will be only covering the first two types, that is the serial input, parallel output, and serial input, serial output, that is SISO and SIPO. In a serial input, serial out registers, as the clock signal is connected to the all flip-flop, the serial data is connected to the leftmost flip-flop. The output of the first flip-flop is connected to the input of the next flip-flop, and so on. And the final output of the register is collected from the outermost flip-flop. Here you can see that for a first clock pulse, the least significant bit of the information will be given into the data input. So that is the least significant bit, and this will be transmitted to the second stage for the next clock pulse. That time the second digit will be given to the D in, and for the next clock pulse the third digit will be given to D in, and simultaneously these numbers will be shifted. And for the final clock pulse, the fourth clock pulse, the final most significant bit will be given to D in, so that finally you will get the most significant bit here and the least significant bit here, and the final output will be get out of this data output. And here you can see the corresponding logic circuit for a serial in, serial out register. The circuit consists of 4 D flip-flops which are connected in serial manner, and all flip-flops are synchronized with each other since same clock pulse signal is applied to each flip-flop. The shift registers which allow serial input, that is one bit information after other like that, and produce a serial output. Since there is only one output, the data leaves the shift registers one bit at a time in a serial pattern. It is normally one of the application of this is in the delay element, which is this can be used as a temporary data storage devices, but main application of this one is in the delay application, delay element application. In a serial in, parallel out shift registers, the data is entered serially and taken out in parallel fashion. The data is loaded bit by bit. The outputs are disabled as long as the data is loading. As soon as the data loading get completed, all the flip-flops containing the required data, the outputs are enabled. 4 clock cycles are required to load a 4-bit word. Hence, the speed of the operation of serial input parallel output mode is same as that of serial input serial out mode registers. Here you can see the corresponding logic diagram. Here also there are 4 flip-flops are used, and the data information is given for a first clock pulse signal. The least significant bit will be inputted here, and for each clock signals this will be transmitted through this, and after 4 clock pulses the data will be here, the Q1, Q2, Q3, Q4, the data information will be available here, and after once the loading is completed the output will be enabled, so that you can get the serial at a time. You can get the all the output here, that is here, this point, this point, this point, and this point you will get at a time. Here there is a clear signal also, so after that whenever one particular operation is completed, you can clear all these for flip-flops. They are used in communication, this type of flip-flops which are generally used in communication lines where demultiplexing of data line into several parallel lines is required, because the main use of this register is converting a serial data into parallel data output. With that, we will stop this lecture on the registers.